Welcome to In 5 Minutes. The agenda of this clip is to study an array multiplier. It is a very interesting concept and it will help us understand how we can make very fast multipliers. Let's get started with the basics of multiplication, and from there on we will jump into array multipliers. Now we know that when we have to add two 1-bit numbers, say my number is A and B, the numbers can take different values, like both can be zeros, one can be 0, other one could be a 1, and both could be 1. We know that if A and B both are 0, my output is nothing but 0. If A is 0 and B is 1, and if I am multiplying, my output is again going to be 0. Again the same case, and when both are 1, it's nothing but a 1. So if we see that the bitwise multiplication is nothing but given, or a bitwise multiplier or multiplication follows nothing but a functionality of an AND gate, which I have shown here, and this is nothing but my bitwise multiplier. This is true when I have to do 1-bit multiplication, when A and B both are 1 bits. But what will happen if I have to multiply two 4-bit numbers, which I have shown here? Suppose this is my number A, which is a 4-bit number, 1011, and this is my number B, which is 1001. What am I going to do is very simple. One of them would be a multiplier, other one would be a multiplicand. Suppose this is a multiplier. I'm going to multiply this with this, put something here, this with this. Simple mathematics, put something here, multiply this with this, put something here, multiply this with this, put something here. And I'll keep on doing this and fill this entire table. Isn't it? This is very simple maths. We have already done this. And then I'll finally add all of this. So I have done that in general terms here, where I have written that my A term is nothing but A3, A2, A1 and A0, and my B term is nothing but B3, B2, B1 and B0. And I have just done the same thing. This A0 is into B0, this A1 is into B0, A2 into B0, A3 into B0, so on and so forth. And so my terms finally would look like this. I will take just first row's example. It will be something like A0 B0, A1 B0, A2 B0 and A3 B0. I'm just going ahead and doing one more case. The second row will look nothing but A0 B1, A0 B2, A0 B3. Is that correct? That's not correct. It's not going to be this way. That's the reason a lot of people tend to make such mistakes. That's the reason I've deliberately shown it that way. Correct. So in next row, it's B1 into all the A's. So A0, B1, A1, B1, A2, B2, A3, B1. Again, see, this is all ones because it's all into B1. Here it was all into B0s. Here it will be all into B1. This is a 1. Similarly, now I'm not going to explain. We have understood this will all be into B2. And the last one would be all into B3. The reason why I'm doing this is we are going to see a very fast multiplication technique, and it's very important to understand all the product terms which are present. So this will be my product term 0. Remember, all of this would be added now. So this will give me my product term 1. This column will give me my product term 2. This will give me my product term 3. This will give me my product term 4. This will give me my product term 5, 6, and whatever is the final carry, because it's an addition, is going to be my P7. We want to translate this and make this a very fast multiplication technique, and that's where we study array multiplier.